this time. I already see something different from last time. So hopefully the live stream is now working. It says we're streaming. So, all right. Hopefully it's good to go. Oops. Let me get me up there, not memo. Ah, that's a problem from the last class we were talking about. Okay. And so what do I want to start with today? I want to start with cross products. Let's get to it. Let me show you a couple of things. I think we're on page 63 in the workbook. Let me see if that's right. 63. And let me bring it up here. Oh, yeah, it's 2 pages off. There we go. So 63 in the PDF is actually page 61. So we're going to try and go over this stuff. All right. So I want to talk about 2 different ways to do the cross products. So there's this piece right here. And these, so 3.9 and 3.12, these sets of information go together. Okay, that's one way to do a cross product. And then the other way to do a cross product would be the combination of 3.10 and 3.11. I suppose had I had any, inclination, I should have grouped them a little bit smarter, but whatever. These are the two different ways that we're going to try and do cross products. So I'm going to start with the Cartesian method, I'm going to call it today, I guess. So that's using these green arrows right here, are the ones that I've shown the arrows with. So I'm going to try and do these 2 problems, or these 2 techniques to solve a cross product. So let me go to the board and just show you what this means and walk you through it. All right. All right, let's just get to it. And on the board here, because we're going to run out of space, I'm going to not include units for this problem, and I'm not going to worry about sig figs for this problem, okay? So we're doing a very simplified version where we focus on the cross product math, and need examples with the units and the sig figs. Those are obviously in the book. So let's focus on the cross product. So let's start out here. Let's say I have a vector here. All right, and where am I? Right about here. Okay, so let's say vector A is 3 in the I hat minus 2 in the K hat. All right. Now, I know some of you are in a math class, and you'll see that in math class, they almost always write +0 in the J hat, -2 in the K hat. And that's a good practice. But 1, I want to write less, and 2, I don't have enough space. So normally you'll always see math teachers write the I hat, J hat, and K hat. That's a great practice. We don't have room for that. So I'm going to leave out any terms of this vector that are 0. So again, this is to the right, and you can think of this as being out of the page. More on that later. Let's say we have another vector here. Let's go red. Oh, let's pick a different number. Okay, and so here's our 2 vectors. One of them is in the I hat and negative K hat. The other's in the negative J hat and the positive K hat. So this one has no I hat part. This one has no J hat part. And now we're going to try and do a cross product. And I'll try and color code these. I'll do my best. So I'm just going to write it out first. I'm not going to do anything fancy. I'm just literally going to write this. And I have to be write it a little bit small just because we run out of space in here. Okay, so here are 2 vectors. I'm going to do A cross B. The order matters. Okay, I'm not doing B cross A. I have to do A cross B. So that means I have to put the A vector first and the B vector second. All right. So what I'm going to do now is just the same old FOIL method that you've always used before. So first, outer, inner, last, that kind of thing. So if I could, that's going to be 3 in the I hat crossed with -4 in the j hat. That's the first term. Then we'll do outer. So that would be, let's see, outer would be, again, I have to keep the order straight. 3 in the I hat crossed with 5 in the k hat. And if you want to race ahead, feel free. First, outer, inner. Ooh, this one's kind of spicy, right? We got negative and negative. So I got a -2 k hat cross -4 j hat. Now I'm going to have to squeeze this last one in here. It turns out the last term is going to end up dropping out anyways, so my apologies. It's going to be a little sloppy trying to squeeze it in there. You can see now why I left off units in sig fig. So sorry if this is going to have to be a little droopy there at the end. Looks like it's going to be, that's, geez, I'm running out of room. All right, so that's just the FOIL method. All right, and now what I want to do is I want to show you how we can get the next step of this problem. There are lots of different ways to do cross products. If you've taken a math class before, the most common way you see in a math class is usually you do a 3x3 determinant, blah, blah, blah. If you don't know what I'm talking about, it turns out it doesn't matter. You don't need to know that. The method that I'm going to show you here is pretty popular with engineers, and it's actually the fastest method for most engineering problems and physics problems. And so you might think that determinant method is the best. And in one case it is, but most cases, this is actually a faster method. I want to show you something on my screen before we go on. So right below these here, you'll see this thing, and I call this the wheel of pain here. This thing I call the wheel of pain. Now, this is a trick. I'm going to write it on the whiteboard. You could read all these words, but I'm just going to show you the stuff, and then you don't have to think about reading, okay? So in this case, I'm going to write that wheel of pain right here. So I know that I hat goes to J hat, goes to K hat, goes to I hat. Now, what does this mean? I'll explain when we do the math. This is a trick for remembering the signs when you do cross products. What this means is if I'm going this way, if I do I hat cross J hat, I'm going with the circle. I would go I goes to J goes to positive K hat. Now, if I go backwards around the circle the wrong way, notice these are little arrowheads here. If I go the wrong way around the circle, J hat cross I hat is going the wrong way. I would get a negative K hat. Now, let's just do this problem and see what I mean. Here is the math that I need to do. I've got a 3 times a -4. That is -12, okay? Now I see I have an I hat crossed with a J hat. From that, I see I goes to J goes to positive K hat. I'm going the correct way around the circle. So all of this is positive K hat. So the numbers 3 and -4, when I multiply them, give me a -12. And the I cross J gives me a positive K hat. Okay. So next, I've got a 3 times a 5. That's 15. So that's the 3 and the 5. And notice I get an I hat crossed with a K hat. How do I do this? I'm starting at I goes to K goes to, what do you think? Somebody unmute.
Would it be J or negative J?
What do you think?
A negative J?
Exactly. Why?
Because you're going backwards?
Yeah, I'm going the wrong way, so I get a negative J hat. Nice job. And so that's how we use this trick. Basically, any cross product, you could still do the FOIL method just like normal. And then when you do it, you have to think about this to get plus minus signs, because with the cross product, the order of the operations matters. We say it's non-commutative, meaning if you change the order, you get you don't get the same answer. All right, let's keep going. If you want to race me to the end, I'll just keep going here. The next term, I got a -2 times a -4. So that is positive 8, making sure I don't screw that up. Then I get a K cross J. Got to keep the order straight. And I should be careful. It's K hat cross J hat. And now in this case, K goes to J goes to, another negative. This is a triple negative. We got negative, negative, and then a negative from the cross product. And you can see why you have to kind of write these out to make sure you don't screw up. What did I say? K goes to J goes to negative I hat. Finally, this last one is actually 0. And let me show you why. Oh, and there's a question in the chat there. Okay, gotcha. Okay. So right here, this is something that you've got to get good at remembering and just memorize, okay? So I want to point out the following. We know that I hat dotted with I hat is equal to 1, but I hat cross I hat is equal to 0. The way I remember it is this: dot products measure how parallel things we are. A vector is always parallel with itself, so I get a big number. A cross product measures how perpendicular vectors are. Any vector is parallel to itself, which means any vector is never perpendicular to itself. So the cross product is 0 because a vector is not perpendicular to itself. And here, a vector is parallel to itself, so I get a 1 there. So that's how I remember that. Okay, this is how perpendicular they are. This is how parallel they are, sort of, kind of. All right. So what that means is this one. K hat cos K hat is 0. And so with a little bit of experience, you could see why this will become a quick process. When you're foiling this method out, you would never even bother to write this term, because you would say, oh, K hat cos K hat, that's going to drop out. You don't write it. Then you go one step further. With engineering, a lot of times one of the vectors is aligned with the x-axis. That means most of your cross products will only have 2 terms. Why? Because I hat cross I hat will drop out, and then you only have the other 2 terms, I hat cross J hat and I hat cross K hat. Or a lot of times you'll just get 2 vectors, and you can see that there's only 3 terms to figure out. I think this is a lot faster than doing determinants, getting multiple rows, getting multiple adjoints. So yeah. All right. Yep. So remember, this was in the Canvas. I expect you guys to actually read too. And I understand that this part's confusing, but in multiple spots in the Canvas modules, it says we're in chapter 2 in the textbook, which is chapter 3 in the workbook. So, all right. I don't know if you could tell, I'm getting a little salty after 4 weeks of class. I'm already getting, so don't mind me if I sound irritated. All right. It's just I've been working too much. All right. Let's finish this problem out. Now you might say we've already done this problem, and I'd say, yeah, well, we should write it the right way. So let's look carefully here. In this case, the standard way to write your answer is not this. This looks like crap. Usually you want to put the I hat part first and factor out any minus signs in front. So in this case, we get a negative times a positive. So it's -8 in the I hat, minus 15 in the J hat, minus 12 in the K hat. And hopefully that's all on the board. There it is. So that is that's the cross product. That's one way to do it. And let me check and see if there's any questions there. Right. Okay. All right. So far, so good.
Can you move the camera down just a little bit? The bottom's cut off. Perfect, thanks.
Is that better? Now the top's cut off a little, right?
Nope, that's perfect. At least
right
for me.
there.
Yep.
Okay. Yeah. All right. And so there's an example. There's another example for you already worked out on page 64 if you need it. At the bottom of 64, I did another one and worked it out in gory detail. And obviously you've got all the problems in the workbook. All right. So that's the Cartesian method. It works great. And like I said, this wheel of pain is really convenient. It just helps you remember these minus signs down here, whether or not you need a minus sign or not, which is similar to in matrix math, doing the adjoint, whether the terms have the minus sign or not, every other one. Okay. All right. Yeah. Other questions? Pause for a second. All right. And remember, at any time you could ask your questions, and I'll try to catch them. Oh, there's one in the chat, maybe. Oh, okay, that's just Jacob. Got it. Okay. All right. Sweet. Okay, good job. All right. So next, let's go ahead and look at the other style of doing these. And let me show you what I mean. And by the way, we're going to get done early today, so there's going to be plenty of time for questions. So just to be clear, we just described this and this. We did a cross product using that and also this wheel of pain down here, okay? All right.
And the wheel of pain is the same thing as 312, right?
Yeah, pretty much. Exactly. It doesn't tell you the zeros, but yeah, it's very similar. Good point. So now I want to try and do this stuff here, all right? And to do this, we need to draw pictures on the whiteboard. So this is the next step that we're going to do. So if you have your workbook there, go ahead and have that handy so I can stop sharing the screen. And we'll go to the whiteboard here. And it looks like the live stream is taking, so you can watch this again later on if you need it. All right. So now I'm going to do another thing first. So let's say this is X. Let's say this is Y. This is my coordinate system. Oh, sorry. There we go. So you have an XY coordinate system. Let's say this is vector. Oh, let's use a different letter. How about P? Maybe that's a pushing force. So it's got a letter P associated with it. All right. And let's say there's another vector over here. I don't know, this is Q. There's a Q vector, all right? I'm just trying to make sure I don't use the same letters all day, that's all. Oh, these headphones, so comfortable. All right, now what I wanna do is I don't wanna get the vector P cross Q, I wanna get the direction of P cross Q. And what I'm going to do is I'm going to follow these instructions that I'm going to show you. So I'm not trying to get the cross product. I'm trying to get the direction of the cross product. Notice the subtle difference in that statement. All right. And so I'm trying to follow these rules right here. What I want to do is I first want to align the fingers of my right hand with the first vector, curl them towards the second in some way, somehow curl them. And then when I get it lined up, my thumb will point in the direction the vector points. So let's see what happens. I line up my fingers with the first vector. Okay. So just so you can see it there. Now I'm going to curl my fingers. They are not going to Q. I don't reach Q. That is not correct. I'm going to try this way. Nope. I'm going to try this way. Nope. Try this way. Yes. So the idea with the cross product, if you're trying to figure out the direction, you first line up the fingers of your right hand with the first vector, try every possible way you can think of, and see which one lines up the best. In this case, P goes to Q. My thumb points out of the page. Oh, let's get psychedelic here. Oh, yeah. Oh, okay. So P goes to Q, goes to out of the page. P goes to Q, goes to out of the page. So in this case, we need a way to draw out of the page. The way we do that is this. A circle with a dot. So this is going to mean forevermore out of the page. Whereas a circle with an X is going to mean into the page. Okay? The way I remember it is this. If I was going to shoot a bow and arrow at you, right? Imagine my finger is the arrow, right? That point is the dot. It's the arrow coming out to poke you in the eyeball, okay? So that's why a dot means out of the page. Now the X, I think of that as being like the feathers of the arrow. Imagine you shoot an arrow, the feathers would be flying away. So the X is supposed to be, it's cheesy. It's super cheesy, but if it works, cool. The X is supposed to be the arrows of the feather flying away from you, all right? So dot is the arrow coming to hit you in the eyeball, out of the page. X is the feathers of the arrow going away from you. So that's what that means, all right? So far, so good. That's just to get the direction. Any questions on that part? Let's pause for a sec. Oh, there's something in the chat. Let me check. Yeah, it works. It's good enough, right? It gets the job done. I don't care how stupid I look, right? As long as it helps you guys lock that in, that's all I care about. So, all right. Next, how would you actually get the magnitude of that? Well, let me show you here. Yep. Let's go to the, let me go to that. So this is how you could get the magnitude of that. Now, so notice you get the magnitude by doing the magnitude of A times the magnitude of B times the sine of the angle between. So let's go to that on the board and take a look. So now we already figured out the direction. I'm just going to write that here somewhere so I don't lose it. Give me a sec. I just need more board space. Direction of P cross Q was out of the page. So now I can erase all this. Now what we could do is, to me, let's just estimate these things. That to me kind of looks like about, let's say that's 110 degrees. And let's say this magnitude was 6 meters. And let's say this over here, let's say this was, 5 newtons. So how would I get the magnitude? Okay, so the magnitude of P cross Q would equal the magnitude of P the magnitude of Q times the sine of the angle between, which in this case was 110. So I'm going to grab my trusty calculator somewhere. Maybe. Sheesh. Where did I put that dang thing? Here it is. Okay. Always check my degrees, radians. Got it. I got 28.19, so let's just say 28.2. Is that right? 28, yeah, 28.2. Is everybody good with that?
Yep.
Nope, I'm not. Why would I not be? Not Esteban. I know you've already gotten this one before. Somebody else. Units. Oh, that jerk. Look at this guy. Why didn't he do this? Oh, okay. All right. So then don't overthink it. Okay. The units are, I'm just going to write newtons times a meter. So the units you can move in any order you want. And I just happen to, I can't stand writing it the other way. That's a standard thing. Somebody else might think of this as a torque, foot pounds. A meter is like a foot, a pound is like a newton. So maybe this is a torque calculation. I was trying to give you a realistic set of units, whatever. All right. And so the idea is the torque here is out of the page. P goes to Q, goes to out of the page. The magnitude is 28.2. So this is a different style. They both have their uses. If you only learn one style, you're going to be slow when you have to do real work. That's just the facts. Okay. So far, so good. I'm going to pause and see if anybody has any questions here. Making some sense? All right. Oh, I see there's something in the chat there. Let's check that out. Yeah. Oh, good, Adrian. You got it right on. Sorry, I was a little slow there. My bad. All right. Okay. There's one last piece of this chapter, and then we're ready to open it up to do whatever you want and practice, and I'll help you in any way you want. Okay. So let's do this last bit. Coordinate systems. Man, this eraser's quickly dying. Oh, man. Okay. Whatever. All right. So I just want to remind you. All right. So, whoops, let me get this back on speaker view so live stream will see it. Let me get it a little lined up. Okay, so all day long, data is going to mean out of the page. X is going to mean into the page. That's just to help us remember. So let's think about this. This is usually X, but not always. This is usually Y, but not always. Different books are even in one physics book, I've seen 3 or 4 different possible ways to write the coordinate system. If you go to math books, there's usually more than one way. So this is the standard way for drawing planar objects, but usually X comes out of the page and then Y is this way and then Z is up. And so there's lots of different coordinate systems. They can all be correct, but this is a big deal. If you want your math to work out and you want to be able to do cross products, we have to make sure your coordinate system is right-handed. Now, what does that mean? Right-handed means it obeys the wheel of pain. That's my short version of saying this. So I'm going to write this down. I hat goes to J hat, goes to K hat. All right. By the way, nobody else says wheel of pain but me, I guess, but whatever. Okay. So in this case, let's think. If we want this coordinate system to be right-handed, I don't get to choose where K hat is drawn. Once you draw 2 of the axes, the other one is determined for you. So line your fingers up with the right hand pointing to I hat. Curl them to J hat. I goes to J, goes to K, out of the page. That means if this is going to be X and this is going to be Y, I have no choice. That is K hat. Now, sometimes you'll see this drawn this way, where Y goes up, X goes this way, and then what they'll do is they'll draw Z going this way. So this is sometimes how that's drawn. And people don't like this, but too bad. You don't, oh, whoops, let me get this down a little bit lower there. Sorry, there's some glare there from the computer screen. There. Oh, geez, there's always glare. All right, there we go. All right, so in this case, X goes to Y, goes to Z. So sometimes if you're trying to draw something, you want to draw it with a slanted view like this so that you can see all three dimensions. That's sometimes useful. Sometimes you want to draw a pure side view. For example, what if you're designing a part that somebody else has to machine? Sometimes you literally draw all the views. Let me give you an example here. A Newton meter is also a joule, but that's different. So, Jacob, I'll answer that later. It turns out there's two different units of Newton meter. One is a Newton meter, one is a joule. There's different cases. So if you're doing a torque problem, you're supposed to know that and use Newton meters. If you're doing an energy problem, you're supposed to know it and use joules. Yay. Don't you love physics? All right. So I guess I did that right now. Let me show you something. So that's just one more way physics is painful. Let me show you something here. I think it's this next one. Nope, next page. Sorry, I'm scrolling too much here. Where is it? Oh, it's right down here. In real life, I'm looking at this part of the screen right here, okay? In real life, usually one version of the picture is not good enough. And so what we do is sometimes we'll draw the angled view, then maybe we'll draw a side view, and maybe even draw a top view. And later on, we'll learn that each time you do this, you have to figure out how the coordinates change. And so it gets a little bit tricky trying to describe things with just one viewpoint. So we'll draw multiple viewpoints. Even better might be to make a 3D model of something. And so trying to bring this up here. Let me get this zoom junk out of the way. Oh, come on. Get this thing out of the way. Zoom. My zoom's okay. So the idea here is this. If we have something in 3D, right, you could zoom in and out. And the idea is this could help you try to get a feeling for X, Y, and Z. Now, keep in mind, there are lots of correct ways. This is a right-handed coordinate system because X goes to Y, go to Z. And right now, how it's situated, let me see if I could do this. This and this are exactly the same thing, right? K hat's coming out of the board. X is to the right, Y is up. Let me show you that again. Okay. So that's, again, X to the right. Zoom. Geez, this zoom is killing me right now. Notice K hat is coming out at you. And again, you can't really see it that well, can you? So that's why people make 3D models in SketchUp or CAD or whatever, and so that you could rotate it. This is like the lower image I have on my screen here, just to show you. This version is the Z coming out. So the standard default is when you have a line coming out of the page, they draw it going down and away like this. So this is X, Y, out of the page is Z. Now it's hard to draw, so you have to know both. Okay, so let me see if there's any questions on that. This is usually uncomfortable for people. Okay. All right, any questions on that? I'm going to give you a practice. Oh, go ahead.
How is it? How the multiplying or crossing two vectors on a x and a y axis? How does that give you a z axis? Like I'm trying to visualize it. So if you have newtons, so you have a force pushing, and then something's also moving at the same time, which is the meters, right?
Okay, let me give you an example. Where did I do that? So let me try and make this a little bigger. The idea here is this is one example. Can you see that at all?
Yeah.
Okay, and then just to make this a little bit smaller so I could see this and this. This is that simulation I sent you. So it looks like, oh, I need just a little bit more room. Sorry. Okay, so the purple arrow here, and I'm going to annotate so you can see it a little better. That's this arrow right here. That is the purple arrow right here. And so that's A. It has a magnitude of 5. Then there's the yellow arrow. That's this crap right here. All right. And then the dot product. We aren't worried about the dot product. We're worried about the cross product right now, right? So the cross product is this. Now, you were saying, what does this mean physically? And I'll explain that. So that's this green arrow right here. So notice it's going negative k hat into the page. So if I could, that's why when we first started looking at it, oh, I got to get those other. All right, give me just a second here. So if I could make this a little bigger again, the idea is the purple arrow is going kind of down and to the right and down. The yellow arrow is also going to the right and down. They both have positive x values. They both have negative y values. And so that's why they're going this way. Notice the green arrow, you can't really see it, but it's pointing into the page. So what does that mean? Imagine if the red arrow was like the lever arm on a wrench. The purple arrow was the lever arm or the distance, and the yellow would be the force applied. The green arrow indicates the axis of rotation when it twists. And so that's what that means. Now, we're going to talk about this in 161. You do not have to understand this right now, but the idea is, since you asked, I'm going to answer. Be careful what you ask, right? So let's say you have a wrench here. This is what cross products are typically used for. So this is part of the course in 161. We don't do anything with torque in this class. So there's my wrench, right? Here's a bolt. Let's say I'm going to try and tighten this bolt. Now you probably could imagine there's an axis of rotation right there. So let's say I pull on the wrench this way. So let's say this is my force. And then this is a vector from the pivot point to the point where the force is applied. So that's called an R vector. But now, what direction is the torque? I got to move around here. Watch. I know that by definition, torque, which is a vector we're going to care about, is R. Whoops, let me do the color code. R cross F. Now, we don't have to do all the math right now, but let's say we just want to get the direction. I line my right hand up. Oh, sorry. Let me get this on speaker view so you can see better. Sorry. Sorry about that, everybody. So here is the question that Esteban asked. I think that was Esteban, right? So I take my R vector, I line up my hands, I curl them to F, and notice my thumb points into the page. That doesn't mean the bolt goes into the page. It means the axis of rotation is into the page, and the bolt is going to twist this way. That's a different right-hand rule we'll learn later. But so, yeah, the idea is the cross product indicates the direction of the axis of rotation if you use your right hand. Is that good enough?
Yeah, no, that thanks. That explains a lot. So it is two vectors on x and y axis will always equal a vector on just the z axis, right?
Right. It could be positive or it could be negative. So, but yes, if you have objects in the XY plane and cross product them, it's either going to be out of the page or into the page, depending on the order that you do the cross product.
Okay, cool. Thanks.
Yep. And so torque is very complicated. We do not want to go any more into that, but the direction of torque is very confusing to students. That's why we save that for 161. All right. That's cool. Okay. Yep. All right. So what was I doing? Oh, coordinate systems. So let me try another coordinate system with you and see if you can get this right, okay? So this is a coordinate system I saw in a physics textbook. This physics textbook, I just flipped to some random page earlier. I found the first coordinate system I could find, and this is what it looked like. It had X going this way, and it had Z going this way. You don't have to like it. That's just the way it was. Which way? Oh, I guess, wait a minute. No, it was this way. I think I had those switched. It was Z and X because we just did that one. I think it was like this is the one that I saw. So now my question is, which way is J hat? Think. We know I goes to J, goes to K, goes to I, etc. This is the pattern. So now think to yourself, which way should J hat be? Check it with the wheel of pain. If you got it right, great. If you didn't, keep checking until you do get it right using trial and error. I'll give you a second. All right. Which vector should I start with? I want to use this wheel of pain. I want to predict J hat. Which vector should I start with, the Z or the X? You guys can chime in. By the way, there is no wrong answer.
I'm going to throw Z out there.
Okay, so if we start with Z, we're starting with K hat. So if I go from Z to X, where should my thumb point? If I go from K to I, will I be pointing in the J hat direction or the negative J hat direction? Follow the circle. Am I going the right way?
J hat, and it'll be pointing up, right?
Let's see. Z, so K hat goes to I hat, goes to downwards.
Up, down.
Do you agree? K goes to I, goes to J. Again, K goes to I, goes to J. That would be J hat. I don't think this is the coordinate system I found earlier because this is pretty weird. I must have flipped something. I don't know what I did. But the point is, this would be a right-handed coordinate system. It is a mathematically legal coordinate system. Now, if you're a left-handed person, I don't know if we have any lefties in the class today, you're probably thinking, man, why do righties get all the fun? All I could say is this. I heard a discussion once. So you might be saying, if everything's so good for right-handeds, why are lefties still around from an evolutionary standpoint? I guess lefties are much better fighters. So because right-handed people aren't expecting punches to come from the left. And so whatever, yeah, you got that going for you if you're a lefty. You may be annoyed with your cross products, but you're naturally a better fighter. So you can fight through the cross products with the best of them. That's my attempt to do something other than boring math today, all right? So if you're a lefty, just know that. I heard that, I think, on NPR once or something. Oh, see, Beatrice has got it. Watch out for Beatrice. Man, that left hook is going to catch you. All right. Now we know, be nice to Beatrice. All right. Yeah, questions about this? There you go. I'm going to do this and see. Right on. Let me check something here. It's funny, on my screen, those come up as just boxes, so I have no idea what you're doing, but that's all right. I probably wouldn't understand anyways because I'm so old. I want to show you something else here. Two things I want to mention here. Where was it? I think it's problem 310 in the workbook. Sorry, I'm just trying to get caught up. So let's make sure we covered everything here before we go on. Okay, this is what we talked about. We discussed you could do cross products using the FOIL method with these two items in red circles. Apologies if you're red, green, colorblind. All right, so I'll use blue here for the other one. This was another way we talked about. That's another way to do cross products. Some facts that you should know. Remember, if you have parallel vectors, the cross product is 0 and you don't need to do any math. Switching the order of the vectors flips the sign. And then this is kind of a fun little nugget for fun. It turns out the magnitude relates to the area of a parallelogram. And remember this, the output of a cross product is a vector. So when I'm asking you questions on a quiz, all the same stuff that applies to vectors in general, I could ask you for the magnitude of a cross product, or I could ask you to get a hat vector or a unit vector of the output of a cross product. The fact remains is basically after you do the cross product, your answer is a vector. It should have I hats, j hats, and k hats. The output of a dot product was a scalar. All right, so that was that part. And then we also said, remember this wheel of pain. I'm telling you, it's a really big deal. It comes in, you can see, pretty darn fast, okay? It works for a great number of engineering and physics problems. This is an example using the cross product. I used the same vectors 2 pages earlier to do the dot product. So if you want, you could compare page 64 to page, I think it was, oh, maybe it was 61. So 61 shows you the dot product of these 2 vectors in all the different ways. Page 64 shows you the cross product in all of those different ways. And there's all the different styles. And finally, this was the last piece we did today. Try to understand these coordinate systems. I'm not going to lie to you. This is on one of the quizzes here. You've got a quiz coming on Monday. All right. And so in this case, there's going to be a question here. You got to know this. Now, a lot of students, there's like 20% of students that really find this difficult. I'm not going to lie to you. It's probably like a 3-point question on this quiz, and then it may not come up again. So if you're really sweating bullets over this, just relax, try your best, and get the best points you can. My advice when you're trying to do these systems, these things are really confusing because people get confused. Remember, down is out of the page. 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 So I typically will take these and immediately try to redraw them in one of these ways down here. Now, this is not the same, but I would take this. Let me just show you this one. So for this one, I would say I goes this way. I hat, K hat goes this way. And according to that picture, is J hat going into or out of the page for system A?
Out of the page.
Into.
What?
Yes. Remember, down is out. Down and Out in Paris and London was a book by what? Oh, geez, I'm forgetting the author's name. Well, that doesn't work anyways because I don't know the author. Down is outwards. Down is outwards. Right? So this is into. Got it?
No.
Well, that's the way it is. If you don't like it, you got to. So that's one you got to just memorize by, right?
So how did it flip? If it's going out of the page, when you change the viewpoint,
look,
how is
so
it
this
into
is
the
a
page?
dot, right? This is a dot, right? This is an X. So J hat is on the into the page axis. Right? This is negative J hat. Wherever I label, this is positive K hat. This is positive J hat. This is positive I hat. I labeled this as J hat. That means positive J. Got it? You see what I mean?
Yeah. Yes, now I get it.
Yeah. And so you could see, I mean, Esteban's been pretty on top of everything this semester. And you could see that he's even getting a little confused by this. It's tricky. So like I was saying, practice these and then immediately try and rewrite it like this. And then it's not as bad, right? This is a lot easier. This version in the triangle here is a lot easier for me to understand. Esteban, do you feel like you got it now?
Yeah, it's because where you put the label is telling you where the positive J is.
Exactly.
That's
so
how
I'm
you
saying
know.
this is positive X value. This is positive Y axis, and this is positive K. Furthermore, we know that this is out of the page, and I know that this is into the page. So you're supposed to know all of that junk I just said. And like I said, there's going to be one quiz question, so probably worth like 3-4 points. You got to try and get that right. Is that cool? Maybe it's only 2. I don't know.
Cool.
Good. That is tricky. So there's your questions to practice that. And just to show you another example that I'm not making this up, okay? Let me see if I could show you something in a random physics book here. Where was that one here? Just trying to find give me just a second. So here's an example. I just flipped to a random page in this physics book. And I'm going to show you, where is it? This coordinate system here. And you can see how they label it in this book. So notice they don't put any arrowheads. They don't say any plus minus. So this is positive X. That's what? Is that a Z? I think that's a Z up there. And over there, that's a positive Y. So that's one way they do it, where X is out of the page and Y is to the right. Z is up. We just saw in standard Python coding. In Python coding, the default is, let me run this one again. So this is the default that Python will go to. Notice X is to the right, Y is up, and Z is out of the page. And if you can't see it, you could angle it a little bit. So the angle definitely helps you see it better, but it's also harder to do the cross products and check the wheel of pain. So that's why sometimes you'll see it angled and sometimes you won't. Let's pause there. And there's lots of different coordinate systems used. I was working in Germany. I had to design some pieces for a laser, and I had to, I was basically putting an aquarium around this laser, and I had to cut holes in this aquarium because it was going to keep gases inside to make sure the laser would operate better, whatever. And so I designed all this thing, and the holes were off axis, so they were not symmetric. And then it turns out they used one XYZ coordinate, and I used a different one. So I did all the design work for nothing, and then had to redo it and made my boss really happy. So yeah. All right, gotcha. Sounds good. So there are reasons you might need to do this. All right. The quiz. There's a quiz Monday at the start of class. And there's two different versions. I originally wrote it, I think I had 35 points on it. And so what I did was I just took about 15 of the points out of each quiz. And so your quiz and the other class's quiz are not going to be exactly the same, but I tried to keep them approximately the same difficulty. For example, cross products and angles of vectors are usually pretty difficult. So I tried to make sure you guys each have about the same amount of those kinds of questions. And I don't know, getting the magnitude of a vector is not that hard, or getting one component of a vector is not that hard. So that kind of thing. And so typically you'll each have one hard question and a couple of medium questions and maybe a couple of easy questions. So, but they won't all be exactly the same. So that's what's coming up on your quiz. Other questions? I'm going to stop the live.